Okay, we will go through the Exemplar questions in the electrochemistry chapter. Before going through it, I will show you some information, some basic information from the book. See, if you write a reduction equation, zinc reduce, and this is the reduction potential, copper reduce, this is the reduction potential is copper. But what if you want the oxidation? If it is zinc is getting oxidized, that is zinc used to zinc 2 plus N plus 2 electron, then what will be this potential? So you have to reverse this equation and reverse this sign also. That is negative 0.76 will become positive 0.76, and this is the oxidation potential. So this is reduction potential, this is the oxidation potential. Okay. So in this equation, you can say copper is getting reduced because adding electron, and copper is the oxidizing agent, that is it's oxidizing the zinc. Copper has more oxidizing power. Yes, has more oxidizing power, stable in the reduced form. Similarly, zinc is getting oxidized. Okay, zinc is getting oxidized and is a reducing agent for the copper. It's a more reducing power, stable in the oxidized form. Okay. So this thing. So K is the conductivity. This is Gibbs energy, and this is standard Gibbs energy minus N of E cell. Okay, N of E is the amount of charge. The minus at unity concentration. Minus RT ln K. This is the equilibrium constant. How Gibbs energy related to the equilibrium? This K is different from this K. Okay. Resistance equal to rho. This is called rho L by A. L length area plus A. This is resistance. Inverse of the resistance is the conductance. Okay. Here G star is the cell constant. So electrode potential, standard electrode potential, this refers to the concentration, molar conductivity, limiting molar conductivity, degree of dissociation, the molar conductivity divided by limiting molar conductivity. This is the quantity of electricity, current into time. Okay. Okay, which cell will measure the standard electrode potential of the copper electrode? Okay, so that standard electrode potential is measured at some particular pressure, that is 1 bar pressure, and at this concentration. So that is given 5. See here, this is the standard electrode potential equation. Electrode potential for the Mg is given below. The graph of E standard electrode point versus log of this. So you have to first simplify the equation. See this equation, log A by B equal log A minus log B. Log of 1 equal to 0, and after simplification this will become like this. There is a constant and there is a variable. Okay, this is like y equal to mx plus c. At starting there will be a constant, then I am steadily increasing. Okay, so based on that, then this is the graph, but constant and steadily increasing. Which of the following statement is correct? Intensive property does not depend upon the amount. Extensive property does. So here this E cell is an intensity property. Intensive, it does not depend on amount, but delta Rg, that is the extensive property. E cell is an intensive parameter, but delta Rg, that is Gibbs energy, is an extensive property. The difference between the electrode potential of two electrode when there is no current passed through is EMF of the cell. Okay. called the electromotive force of the cell when no current is drawn through the cell. Here you see which of the following is not correct. They are asking of the inert electrodes. Okay, it does not participate in the cell reaction. This is correct. So it does not participate. They are asking what is not correct. It provides surface for the oxidation order. This is also correct. It provides surface for the conduction of electrons. This is also correct. It provides surface for the reduction. This is not correct. It provides either oxidation or reduction, not both. So redox reaction. This is wrong. Why? Inert electrodes surface for oxidation or reduction, not both. The electrochemical cell can behave like an electrolytic cell when the external voltage is greater than the E cell. Okay, 2. See here, you see when external voltage is greater than, then it will become electrolytic cell. See, the reaction not in the it is now in the as a electrolytic cell. So the current flows in the opposite direction and it behaves like a electrolytic cell. Which of the following solution of the electric is not correct? Okay. Conductivity of the solution depends upon this. This is correct. Okay. Conductivity depends on this is also correct. Conductivity does not. This is wrong. Conductivity of the solution increases with this amount. This is also correct. See here, conductivity depends upon these are the parameters. Using the data given for the strong at reducing agent. Okay, reducing agent is the one with the least voltage potential. Okay. See in this table, if we go up, this is the oxidizing agent, strong oxidizing agent. Whereas if we go down, this is the reducing agent. So go up, that is higher value strong oxidizing agent, lower value reducing agent. The hydrogen is the reference voltage here. So this is the stronger reducing agent. The oxidizing agent which has the more voltage, this one. Using is which is upon the order of reducing power. Reducing power means the reducing agent, which has the reducing power. So this is the strong reducing agent and this is the least reducing agent. In data given below, most stable in the reduced form. That is the most stable is the strong oxidizing agent. And here is most in the oxidized form. There is a strong reducing agent. Quantity of charge required to obtain the 1 mole of aluminum in this. Okay. So here from this you can see it is required 2 mole of electron, 2 farad, and 3 mole for the aluminum, 3 farads. So this is the equation. The cell constant it will be constant. Okay. Change this is constant. Okay, this is the cell constant. Okay. While charging the lead battery, they are asking why PbSO4 anode is reduced to Bb. So they are asking while charging 25. See, on charging, this equation will be reversed. Okay. So this is limiting molar conductivity. So here They are asking for the NH4OH. See here NH4Cl is there. Here NaCl is removed. Na from this, Cl from this. So the remaining NH4OH will be there here. So you can go through this how they are finding this limp conductivity. In the electrolysis sodium chloride solution, which operation at the anode? So this is given in the 23. So this is at the cathode. This is at the anode here. Anode. This is taking place on the account of the over potential of the hydrogen. This won't take place. Only this take place. Multiple choice questions. The positive value of the standard electrode potential indicates a strong oxidizing agent that is going up on the table, and it cannot displace because the less reactive than the copper is less reactive than the hydrogen. When we move up, move down, then it is reactive. For some operation on the basis of this, choose the correct answer. Okay. And dilute sulfur hydrogen will be reduced at the cathode. In dilute sulfur solution, water will be oxidized at the 23. During the electrolytic sulfur this following reaction take. This is the one. So at equilibrium, how this equation changes? E cell is 0 at the equilibrium. That is a potential is 0. 9. See, when at the equilibrium E cell is 0, then if you apply these things, then you will get this formula. Conductivity of the electrode solution depends upon the nature of the electrolytes, concentration of the electrolyte. 13. So conductivity depends on these are the parameters. H2O. So here HCl is there, Na1Cl will be removed here, Na will be removed. So HOH, so H2O. Same thing here also. Okay, similar thing is given here. What will happen to the electrolyte of the aqueous solution of the copper sulfate? By using here they are asking platinum electrodes. Platinum electrodes they don't participate in the reaction. That is the so copper will be deposited at the cathode and oxygen will be released at the anode. So they don't participate in the reaction. They are inert electrodes, platinum or gold inert electrodes. 22. Copper is deposited at the cathode. But if you use copper electrode, they will participate in the reaction. So here they are using copper electrode for the same electrolysis, but copper will participate in the reaction. So copper will deposit cathode, but anode copper will dissolve at the anode. C will participate in the reaction. Conductivity K. This is given in the book. Okay, these are the equation for the conductivity. And this also equation related to the cell constant. Molar conductivity of ionic solution depends on the temperature and concentration of the electrolyte solution. Okay. Molar conductivity increases with the decrease in concentration. For a given cell, this is anode and this is a cathode. Because left side anode is the written and the right side cathode. So C is the cathode and the cell reaction. Left side oxidation anode, right side reduction cathode. Okay. Okay. Short answer type. Can absolute electrode potential of an electrode be measured? No. Answer. No. You cannot measure the absolute electrode potential. Can E cell and delta G cell potential ever be equal to 0? That also no, it can't be 0. Only at equilibrium this can be 0. Under what conditions E cell will 0? When the cell reaction reaches equilibrium, then it will be 0. The cell potential and the Gibbs free energy. At equilibrium, E cell can be 0. What does the negative sign is represent? Negative represents a strong reducing agent. Okay, it is going down. It means that zinc is more reactive than nitrogen. When zinc electrode with connected with the and hydrogen electrode, zinc will get oxidized. Oxidized, that is a reducing agent, strong reducing agent, and H plus will get reduced. Oxidized, that is a reducing agent. Aqueous copper sulfate solution and nitrate solution are electrolyzed by 1 ampere current for 10 minutes in a separate electrolytic cells. Will the mass of the copper and the silver deposited at the cathode be same? No, it can't be same because of the different values of the mass of the copper and the silver. See here, they are finding the how much copper deposited using the this molar mass of the copper. So that mass will be different for copper and silver. So that will be different only. So different. Depict the galvanic cell in which cell reaction. Okay. And this is that reaction. Okay. Copper and silver. Anode left, cathode right. Values of the standard electrode potential of oxidation of chlorine ions is more positive than the water. Even then, the electrolysis of the aqueous solution in the chloride. Why Cl is oxidized at the anode? Okay. Under the condition of the electrolysis of oxidation of chloride, oxidation of water at the anode requires over potential. Hence, Cl is oxidized instead of the water. So you can go through it, see why Cl is oxidized at the anode here. Okay, on the account of the over potential of the oxygen. So water is not oxidized, only Cl is oxidized. So lower, but because of this, Cl is prepared. What is electrode potential? This is the potential difference between the electrode and the electrolyte is called electrode potential. Consider the following diagram in which the electrochemical cell is coupled with the electrolytic cell. What will be the polarity of A and B? See from the table that is reducing potential mentioned. So you will get negative 0.76 for the zinc electrode A and 0.34 for B. So you'll get a negative polarity here and positive polarity this side. A will have negative, B will have positive. Why is alternating current used in measuring the resistance of the electrolytic cell? DC current changes the composition. That is why we are using the result is the alternative current source. Okay. Measuring the resistance, so we have to firstly passing the direct current changes the composition. That is why we are using AC current. In a galvanic cell, has electric potential 1.1 volt. If the opposing potential of 1.1 volt is applied, what will happen to the cell reaction and the current? It will flow in the opposite direction. See, they are applying opposite voltage. So, electron flow from this to this. Zinc is deposited. Okay. How will the pH of the NaCl solution be affected when it is electrolyzed? 39. The pH of the solution will rise as NaOH is formed in the electrolytic cell. NaOH is formed, that is why pH will rise. Okay. So NaOH is formed, that is why pH will rise. Because of this equation. Unlike the dry cell, mercury cell has the constant cell potential throughout its useful life. Why? 40. Ions are not involved in the overall cell reaction of the mercury cell. Mercury cells ions are not involved in the overall cell reaction. The cell potential is approximately 1.5 volt remains constant during its life as the overall reaction does not involve any ion in the solution. Solutions of two electrolytes A and B are diluted. Okay, this molar conductivity of B increases this 1.5 times, but A increases 20%. Which of the two is the strong electrolyte? Justify your answer. So here B is the strong electrolyte. Uh, Electrolyte B is the strong electrolyte, as on dilution the number of ion remains the same. Only interionic attraction decreases, therefore increase in delta is small. Okay, for B the increase in delta, this is molar conductivity is less. You can remember this graph. See this molar conductivity graph of this strong electrolyte and weak electrolyte. See here the strong electrolyte remains almost constant. That's so, but weak electrolyte drastic decrease. So when the acidic HTSO solution is electrolyzed, will the pH of the solution be affected? Justify your answer 42. pH of the solution will not be affected, as H plus concentration of the hydrogen ion remains constant. At anode, okay, there are 4 hydrogen ion, 4 hydrogen ion. Cathode 4 hydrogen, 4 hydrogen. So the concentration remains constant. So pH will not be affected. 42, 43. Okay, this is the zone. So you have 4 hydrogen ion here, 4 hydrogen ion here. In aqueous solution, how does the specific conductivity of an electrolyte change with the addition of water? 43. Conductivity decreases because of number of ions per unit volume decreases. Conductivity decreases. Conductivity always decreases with the decrease in concentration. Which reference electrode is used to measure the electric potential of the, so this is hydrogen electrode only it is used. So on 44. Standard hydrogen electrode SHE is the reference electrode when electrode potential is taken as 0. Whose electrode potential taken as the electrode potential of other electrode is measured with respect of the this. So here this is zero potential and this is taken as reference. Consider cell reaction anode cathode. Reactions occur at the anode and cathode. Anode oxidation reduction. Answer 45. Oxidation of copper, reduction of the chlorine. Write the energy equation of this cell reaction of the linear cell. How will it be affected with the concentration of the zinc ion increases? And this is this equation, and increase this concentration, this value will increase, so the overall this will decrease. Okay, the cell value, cell potential will decrease. Okay, concentration increase. Okay, and increase this cell potential will decrease. What advantage do the fuel cells have over primary and secondary batteries? Primary batteries contain limited amount of reactants and are discharged when the reactants have been consumed. Secondary batteries can be recharged but takes long time to recharge. Fuel cells runs continuously as long as reactants are applied to it and products are removed continuously. Right, the cell reaction of the read storage battery when it is discharged. They are asking it discharged. How does the density of the electrolyte change when the battery is discharged? This is the cell reaction. Density of it decreases as the water is formed and sulfuric acid is consumed as the product during the discharge of the battery. This is the reaction. This is the charging reaction. This is the this charging reaction reverse of this reaction. Why the dilution of while on dilution, molar conductivity of this increases drastically while the in case of CH3COH, this is a weak electrolyte. The number of ion increases due to increase in the degree of dissociation. Okay, in case of the strong electrolyte, the number of ion remains almost the same. I already showed you that graph. Um, okay, how strong electrolytes behaves, how weak electrolyte behaves. Okay, matching type. The column 1 match. So this is the molar conductivity. So this is the unit. Okay, Siemens E cell voltage. This is the conductivity. Okay, this is the unit. This is cell constant. Column 1 say molar conductivity increases with the dilution. Cell is a intensive property. It does not depend upon the amount. Conductivity depends on the number of ions in volume. Gives energy. That is a extensive property. It depends on the amount. Lead storage battery. Okay, this is in the anode. This is cathode. Mercury cell. Steady potential. Fuel cell. Maximum efficiency. Okay, roasting prevented by galvanization. Conductivity, and this is the I already showed in the book. Molar conductivity. Molar conductivity, and this is on degree of dissociation alpha. This is molar conductivity by limiting molar conductivity. Quantity of electricity current into time. Cell, some cell, somebody's name. D. Cell reaction, this is the one. And this cell, rechargeable. Fuel cell. Cell reaction, fuel cell. Converts energy of the combustion into the electrical energy. Mercury cell does not involve any ion, okay? Match these following. So the reduction potential is given for fluorine. non-metal best oxidizing agent, and the tablet is in this top oxidizing agent. Okay, this one metal strong reducing agent, and this one, yeah, this is oxidizing agent. So you can go through these things from the table. Okay, assertion. These are the reason both number one selection mean both assertion reasons are true, and the reason is the correct explanation. So now copper is less reactive than the hydrogen. Copper is less reactive. No, this is copper is less reactive based on the electric potential. That is positive, I think. So 3 assertion is true, but the reason is false. Okay, this reason is false. Copper is less reactive, that is true, but the reason is false. Cell should have a positive value for cell to function. That is assertion is true, but the reason is false. Conductivity of all electrolyte decreases on dilution. On dilution, number of ions per unit, so both reason and assertion is true. Molar conductivity of weak electrolyte shows a sharp increase when this weaker electrolyte degree of dissociation increases, and yes, weak electrolyte dissociates fast. Reason and assertion both are correct. Mercury source does not give steady potential. No, this is wrong. So this is 5. In cell reaction ions, this is C5. 5 assertion is false, but the reason is true. Assertion electrolysis of NaCl solution gives chlorine at the anode instead of the oxygen. This is correct. Formation of oxygen at the anode requires over voltage, and this is correct. Both assertion and reason are correct. For measuring the resistance of the ionic solution is AC source. Yes, correct. AC source only used. Concentration of the ionic solution will change if yes. Composition will change if DC source is. These both are correct. Reason assertion. Current stops flowing when E cell is zero. Equilibrium of the continuous. Both are correct. Increases with increasing concentration of the Ag plus ions as a positive value. 2. Both reason and correction are true, but the reason is not the correct explanation. Copper sulfate can be stored on the zinc vessel. Zinc is reactive than the copper, less reactive. 4. Both assertion and reason are false. Long answer type. Consider this. Okay, cell A 2 volt and cell B. Which of these two cells, C or B, will act as an electrolytic cell? Which electroreactions will occur at the cell? Cell B will act as electrolytic as it has a lower EMF. Okay, the electroreactions, okay, these things. If cell A, okay, they are now changed the voltage, then what will be the reactions at the anode and cathode? Now B will act as a galvanized its higher EMF and push the electrons into the A. This is the reaction. Read the diagram to show the direction of the electron flow. Direction of the electron flow. Zinc to silver. zinc to silver electron flow. Silver plate the anode or cathode. Okay, so silver cathode. Silver is a cathode. What will happen if the salt bridge is removed? Okay, so no reaction. Stop functioning. When will the cell stop functioning? This voltage is zero, potential is zero. How will the concentration of the zinc and silver ions be affected when cell functions? Okay, concentration of the zinc plus ions will increase and the concentration of Ag plus ions will decrease. How will the concentration of zinc plus ions be affected after cell becomes dead? So it will not change. Is reached, the concentration of will not change. What is the relationship between Gibbs free energy of the cell reaction in a galvanic cell and the EMF of the cell? What will be the maximum? Okay. This is the relation between the Gibbs free energy and the cell potential. Okay. So now you can go through these solved examples in the book also, so that you will get familiar with the battery functions.